Yeah,
Yes,
yeah,
Yeah,
yeah.
yeah,
yes.
you're audible. Please.
Okay, sorry for the late. I'm saying participants are very less. I think 83 only. I'm expecting means last time yesterday we saw around 148, but still we are 12 minutes more. Means 12 minutes already the session started, but still I'm not able to see 100 plus participants. Sir, can we wait or can I start now only?
So I think we should start. And one of our participant request to go slow a little bit. Yeah, that's one request I got.
Yeah, actually, slow in a sense, these are advanced topics, and we have a huge content also, like information also to discuss. So that's what I
Yes, yes.
used to. Yeah, I am. Means I am. Many times I used to stop and repeat the things to make everyone in a same page or everyone in a same path. But I will try to do that. And one more thing. So today's topic. So again, I'm following the same format. The format is first in first half we will discuss what is the real time problem or what is the project we are going to solve in this session, and then later on what is the theoretical knowledge or what is the technology or what is algorithm and what is required and how it is means how it is works or what is the information behind like technically, so that we will discuss in part 2. And then after that I'm going to show you hands on like how to solve our problem based on whatever we learn, during our learning means our understanding. So basically this is the standard template I used to follow. Okay, so yeah, yesterday also I told the same thing, but yeah, this is the format now. Yeah, so today we will start our session. I'm going to start 88 are there, so okay. Yeah, so actually want to make a connection. Yesterday also I told you, no, like I'm going to give a connection to yesterday's session as well as today's session. Means connection in a sense continuing. I mean continuing. So yesterday's session is about beginning to intermediate level. So today's session is about intermediate level to advanced level. So I feel today's session is something very real time and useful for all peoples who are looking for computer visions problems. So today's in our session we discuss on computer vision problem basically. So yeah. So and we are going to solve means with respect to computer vision problem only. It's not everything. So means NLP or ML or something like that. So that is a one point. And second point, it seems to be very information wise. It seems to be bit huge. But I request everyone try to understand. I will try to explain in a very simple and very English understandable way, like as a giving less information about technical perspective. Like initially, after that, I will provide more information and technical terms and all. But I feel this required more concentration and continuity while listening or while going to the session. So I request all participants, please concentrate on what we discuss. It is very useful, I can say, who are working on computer vision problem basically. So we are limiting to computer vision only, not going everything discussed in a single session. Yeah. So that is a small update on today's session. So now I'm going to start today's topic. So actually, this is our hands-on code. I'm just running the code background because it taking very huge time. So I'm not able to. I think I'm not able to make you everyone to feel the real time means hands-on means live coding, because here you can see for each epoch it taking this many minutes and this many seconds, like 1234 seconds, which means 1234 by 60 seconds, which is equal to roughly six, like I can say how much, like 6 2 2, then it's around
Sorry
20
to interrupt.
for each,
Sir, are
for
you
each.
sharing a screen or like we are not
Oh,
able to
sorry.
see your
Yeah,
screen?
yeah. Sorry. I thought I'm sharing my screen.
No problem. Thank you, sir.
Yeah. So yeah, I hope everyone is able to view my screen. So and one more point, if same thing as yesterday, like if anyone has any question or any doubt, please raise your hand and I will give you some means time to you to ask your question. So whenever anything requires, please raise your hand. Okay. So today's our problem is now I'm going to show you the problem. So basically, the main purpose of the session or the main purpose of the session is to understanding how this ML projects and how a ML means how one project like ML computer vision problem is going to solve, or what is how it is solved, and what is the algorithm we are using, and how that algorithm works, and what is the mathematics behind that algorithm. So something like this, something like uh, uh, something like not focus on the problem statement. Here I'm not very focused on the problem statement or not focus on the project. I focus on uh, how to use ML or how to use this algorithm on the problem, on the how to solve the problem using ML algorithm. So that is the main agenda for session. So today's our problem statement is regarding we need to identify the types of diseases present on cassava leaf. So basically, cassava is a kind of leaves, means a kind of food for most of the. I think we can see that cassava, cassava plants, and we can see that. So this is a cassava. So cassava. So this is the information regarding cassava. Cassava is like a eatable food for African continent. So like here you can see cassava is a nut flavored Latin vegetable and tamar. So it is native to the South America as well as South African people also. So this is a very second highest, means second popular crop in South Africa and that regions. Here you can see as the second largest provider of carbonates in South Africa. So cassava is a key food security crop growing by the smallholder farmers because it is with outstand harsh conditions. So in Africa, the weather conditions are very tough. So means it is not very good. So that's what cassava is a very good food craft which is able to means which can able to handle all kind of weather harsh conditions also. That's what most of the small hold farmers used to grow the crops like cassava only, and this is the very key food security crop for the people in South Africa. And so I just give you idea what this cassava leaf and all. So now what is the problem we have? So basically in this graph there is a in this graph the leaves are there, right? So in the leaves there is a type, there are different diseases are diseases we can see. It's basically every crop having different diseases. So here also we are there are different diseases are there actually. So what we need to develop. So we need to develop a solution using their data. So here their data. So can you identify a problem with cassava plant using the photo from related means photo relatively inexpensive camera with very less camera, means real, it is completely a real time way to say, hey, if you have a very low configured mobile phone, like very smart simple or less configured Android phone, if you provide the image of that plant or image of that cassava leaf, can you identify the what the problem with that leaf? So that is a question he raised in the project data description. This competition will challenge you to distinguish between several diseases that causes the material harms to the food supply of many African countries. Infected plants to prevent further spread. So, which we can make a rapid automated workaround quick useful to the farmers. So, what they are trying to do is, see, out of several diseases, only few diseases are very dangerous. We are not able to do anything on this diseases. But most of the diseases, if we treat the diseases, then we can save our crop from the diseases, right? So but handle that diseases, and it is easy for to overcome, means it is easy for to cure the crop from the diseases. But if the disease is somewhere around level 3 or something like that, like level in a sense very complex, then it is very hard. So what the point is, whenever in level 1 itself we used to find the diseases, then only it is very easy for everyone to protect the crop. So that's what, every time whenever the diseases comes, so we need to find the diseases. So in initial stage itself, we if we control, then we can save the crop. So that is the agenda. So that is the problem statement we have. And with respect to data, they are giving data with respect to training images as well as the test images, and they are giving information here like the diseases names: cassava bacterial blight and cassava brown streak disease, uh, green mottle. Healthy is a plant which is means healthy is what we are looking for. Remaining are the all other diseases basically. So there are 5 diseases are there, and they are giving data sets, and the data also very huge. The data is 6.19 GB data they are providing, and with respect to diseases. And this is so what we need to try to do is whenever so based on our training data set, so after train our model, then if any new diseases, means whenever you give the, after model is done and everything is done, after our deployment also done, so then if you provide a new future sample, so that is not known, or that is comes future sample, if you provide any future sample or future image to the model, then model is able to successfully able to figure out the disease, what kind of disease it is. So that is the main motto for this task. Okay, that is the main agenda. So here that is with respect to problem statement, and so we can see the data uh, point 2, then we can see the evaluation matrix. In evaluation matrix, we are using again the same evaluation matrix, but here we are using categorization, like accuracy. It's a kind of different accuracy, but in a high level, the evaluation matrix again we are using accuracy. This categorical accuracy is something with respect to categories, but I will show you what exactly. But we are using the evaluation metrics also accuracy here, and this is with respect to timelines. What is the competition? Basically, this is a competition timeline, prices, and all. So it is not necessary for us. So for our agenda to understanding the problem statement, to solve the problem statement, what based on our learning, means based on what we learn and using algorithm and all. So this is the problem statement, and this is the evaluation metrics, and this is the data we have. So this is with respect to our uh, first part. Anyone has any questions and doubts on this, please raise. So I'm going to now, next we will going to discuss how we are going to solve this problem, means with which algorithm we are using, what kind of concept we are using to solve this problem. So we will see in our slides regarding that. But before that, I just want everyone, uh, is the problem statement and evaluation matrix and data sets, and regarding that information is clear. Please raise
Yes.
hand if anyone has. Otherwise, I will move to the next topic. Okay, I think everything is clear for everyone. So solve in our session. So this is the this is the project we are going to solve, and basically this is a research project actually. So we need research in a terms instead of applying one algorithm, we need to try to apply different algorithms and finally figure out which is the best algorithm to solve this problem. So that is a purpose. That's why they mention it as a research code competition. So yeah, this is the information. Now let's look into the transfer learning. So today's topic is transfer learning and solving this image classification, like disease classification using efficient net. So okay, so first so next topic, I mean in slides, I'm going to discuss more about the transfer learning. What is the transfer learning, and anyone has any idea about transfer learning? Please raise hand. Any very high level idea also? Okay. Like otherwise, I'm going to explain. Since I'm going to start, but I just want to know if anyone has any idea or anything about transfer learning. Okay, so let's start our transfer learning. So yeah, so today's we are going to learning and image classification using efficient net. So this is the topic for us. Okay, uh, yeah, give me a minute. Yeah, Akanksha, you raise hand. Can you please let me know what is your question?
Yeah, so basically, we're asking about transfer learning. I don't know much, but it's a model in which we use pre-designed model. We do not design a new model from scratch. Either we use a pre-designed model to, transfer the information and to, use the information in the deep learning projects.
Yes, exactly. That is exactly uh, a high level introduction about the transfer learning. Transfer learning is something whatever one person learn, like whatever one architecture learn, gives this information to the other model to get better learning basically. So this is like a transfer in we will see in detail. That is the main point. It's simple in a very simple English, or with a very simple example I will explain. Like if you know the bicycle, if you know how to ride a bicycle, it is easy for you to how to ride a bike. Clear? Like if you already have an idea about how to ride a bicycle, then you can use this knowledge or this learning knowledge, and you can apply that while driving bike, and you can do it in a better way instead of knowing everything from scratch. Like if you don't know about bicycle also, if you are directly taking a bike and try to learn the bike, instead of that, if you know the bicycle already and you know how to ride the bicycle, then it is easy for you to understand the how to ride the bike. Correct? Yes, no, like any question or anything, any comment on that? Like anyone?
Okay.
Yeah,
Clear.
so it is, yeah, so it is right, it is correct, right? So this is called like, this is like a very simple way of saying transfer learning. Very simple to explain about the transfer learning to the normal schools children. Yeah. So let's start with our slide. So I will explain everything in detail. So yeah. So now let's see the transfer. What is the transfer learning? Transfer learning is a like knowledge transfer or domain adoption. So the aim is to apply the knowledge learned previously to solve the new problem faster and with a better solution. We can solve the problem without this previously having knowledge, but we are not going to solve the problem faster as well as in a better way. Correct. So that is the main advantage of getting transfer learning. So what my point is, yesterday we did our own network, right? Own convolution network, and we develop our own convolution network for image classification. At the time, we are getting around 79% accuracy, right? I hope means if you remember yesterday, if that values. But whenever we are applying VGG, fine-tune VGG, we are getting around 90% accuracy. How that is means how it is possible? My question. So what we are doing there, we are transferring VGG knowledge or whatever the VGG learned during VGG train means during the training. So then we are going to apply the learning of the VGG to solve this image classification problem. Whether which is not exactly VGG previously learned. Basically, it is not exactly like VGG is never work on that kind of same data set or something like that. But still, VGG can transfer the knowledge, and that is the advantage of transfer. So that is the main thing. So in industry, in I can say in industry or in research also, most of the computer vision's problems are solving using transfer learning also. And transfer learning is a very real time and very advanced and real time implementable technique or algorithm approach. Okay. So our aim is to apply the knowledge learned previously to solve the new problem or faster with better solution. Okay. So now transfer. What is transfer? How to transfer? When to transfer? Learning. Machine learning schema related with other machine learning texts. So basically this is the thing. So and one more disclaimer from my side. Whatever I'm showing in the slides are taken taken from different resources, and I'm giving a credit to those people who prepare the resources. But we are using the resources to learn the things. Basically, I'm using these resources to explain and to give a learning to everyone. Okay, so in top level conference, 7 papers in CVPR like computer vision and image pattern recognition 2014 are related with pattern transfer learning. And almost if you see all top research papers, like all top research conference, most of the conferences and in computer vision conference especially, 60 to 70 percentage of papers accepted papers are using this transfer learning, I can say. So that much of popularity and that much of real time implementation transfer learning can get. So that is the main advantage with using a transfer learning. Okay, so here you can see. So here if you so here it's something like this. So here you can see if our model like here you can see if you know whether this image is elephant or not. So then if you know that information, whenever you are applying on that kind of work, or if you applied on the related task, then it is easy for them to differentiate the image or to differentiate the class and the image information basically. So here you can say this is supervised learning perspective. Like here, this is with respect to elephants, and this is with respect to some other animal. So here it is very clear. So whenever you learn about this elephant, then whenever you are apply means we're applying this knowledge on this. So then he says, hey, if something is like this only elephant, if something is like this, it is something with new class. So here also you can see. So transfer learning is something we learn already with the knowledge of previous experience. We can apply this knowledge on solving a new problem. So that is the main concept of transfer learning. Okay, the supervised learning. So like here some description given, like supervised classification uses a label example of elephant and what supervised. Okay, it's like a difference between the supervised, unsupervised, and transfer learning. Okay, so this is like a very what is transfer learning. So the motivation, why we need a transfer learning. So here the labeling data is more expensive and limited, and related data are cheap and sufficient. So what it means? So if we know, like, see, if we have a idea about some classes, like if we already know the label of some classes, so we can apply that knowledge on the new classes. Means we can apply that knowledge on others. So then we again no need to work on the labeling, and we no need to work on other kind of labeling task. So that is expensive. Like if you put some set of people to work on labeling, so that is limited and it is going to be expensive. And one more point, but if you use a pre-trained like already existing knowledge, then it is and if is something if the new information is related to that data, so then you simply take the label of that data and make it as a same label. So then that is sufficient and cheap, right? So that's why most of the industry people are adopting this transfer learning. So basically, the transfer learns is mainly useful for efficient, as well as it will useful whenever you are using the similar data. So then there is a very no need to work on means the efficiency. I mean, the labeling not very labeling kind of works is not required. So here you can see. So yeah, here you can see, if you know in image data in ImageNet, you have some images. Like here you can see the skateboard. Like here you can see the skateboard. If you are going to use this information, like in ImageNet we have a skateboard and mission, like and sandwich. So this information is already there. And what I will tell you, I think this is not a way to explain. So what happens? So some pre-trained model is already developed. Some pre-trained model is developed, that is called as efficient net. So that efficient net is something some kind of neural network is developed using this ImageNet. So using ImageNet data set. Okay. So then so you are going to use your own project. You have your own project, and you want to uh, yeah you want to use your own project. At that time, in your own project and in your own data set, there is no requirement of saying something the data which is available in ImageNet, something the skateboard is already present in your data set. It is not required to say it is skateboard, something like that. So we already have the knowledge in ImageNet, and that is trained in EfficientNet. So whenever you use this model as a transfer learning while training your problem, so then it is easy for you to get that information. And at the same time, there is no requirement for you to again labeling, again doing kind of labeling, and these things are not required. So it will saves the our time, as well as it will it is it we can get a huge data also. Like there is no limitations also. Like if you can see in ImageNet, there is millions of data, millions of images are there, and millions of like thousand labels are there. So in your own data set, probably you can use, you need to use max to max 10 labels or 100 labels only, 100 classes only. So then in that case, and with limited size data only. So in that case, then this transfer learning placing very good role. So using this limited data only, you can get a good accuracy, because we are already trained something on a huge data set. We are applying, we are giving that knowledge to the our project. We are giving that knowledge to the our project. So that is how why this transfer learning is useful. Okay. Yeah. So then there is no requirement of labeling here. There is no requirement of labeling. So that is the point actually. So here with the terminology, there is a kind of few things are there. Like I think I will explain you these 2 points after some slides, because if I explain here, it's something with respect to mathematics things. So I will come to later this point later. Okay, so yeah. Here, what is transfer learning? Which is a part of knowledge can be transferred across the domain. Yeah. So what we are transferring is, we are transferring the feature representation, parameter settings, and latent features distribution. So what it means? So whenever you train the model, right? If it's if ImageNet is this EfficientNet is there, so then EfficientNet is trained on ImageNet dataset. Okay, so EfficientNet is trained on ImageNet dataset. Then during the training, this model will learn complete information, features in an ImageNet dataset, right? So those features are useful. So basically, those features are useful. So we are transferring those features basically. Okay, so that's what here asking, like which part of knowledge can be transformed, like transferred across the domain. So first part is feature representation, because we already train our EfficientNet on image data. So at that time only we can get the complete features with respect to each data in ImageNet under this model. Okay, so whenever you transfer this model to the so this model to our problem, so then at that time itself we are going to utilize the complete feature representation of this complete things. We are going to utilize this complete feature representation things in our project. So this is the first advantage. And second advantage, parameter settings. Yesterday I told you this hyperparameter tuning, right? So based on the hyperparameter tuning, we can get the good models. So this EfficientNet is already trained with good hyperparameters. So we can utilize those hyperparameters values. So that is called as hyperparameter settings advantage. And latency feature distribution, again with respect to features and their feature latency distribution. How transfer learns, how to transfer that knowledge. Basically this how to transfer is I will show you exactly in a coding session. Like instead of developing from scratch, we will develop on top of the existing thing. So that is how we are transferring. So this is our own custom, this is our own standard in CNN, right? But if we apply the CNN, but we are going to use the CNN before EfficientNet. So if we use the EfficientNet first, on top of EfficientNet, if you apply the CNN, then that is the way to transfer the knowledge of CNN, means knowledge of this EfficientNet model. So that is the way actually how to transform the knowledge. When to transform? Ask in which situation transforming skills should be done. Likewise, we are interested to know in which situation the transform situations knowledge should not be needed to transform. Like here, based on our problem statement only, we can conclude like in this case we need a transform learning. Otherwise, we are not required the transform learning. So something like that. We need to when to transform is based on our situations and our scenarios. We need to take care of that. So here you can see there are different categories of transfer learning. So here you can see this is the first transfer learning. So here you can see the transfer learning. So if the transfer learning with respect to no label data on both source and target, so then we can consider as a unsupervised transfer learning. If the transfer learning with respect to label data in a target domain, so then it is called as inductive transfer learning. And the label data is available only in source domain, so then it is called as transitive transfer learning. So there are different transfer learnings are there. So one is self-taught transfer learning in this case, and this is multitask transfer learning, domain adoption, and sample selection bias, and covariance shift something. So these are the different categories of transfer learnings we are available based on category of the problem we have. Okay, basically we have majorly supervised, unsupervised, right? So based on that, we have different transfer learnings. Now let's see the transfer learnings and their applications with respect to application perspective. How this transfer learning works? Okay. Yeah, the main idea of transferring learning. So here you can see the knowledge transfer for automatic image annotations. Here you can see the main idea: learning a new classes called target is helped by labeling the label example of other related classes. See, for example, if you want to classify, means if you want to find the label for one animal, like if you have if you we have a different animals, right? So so some new animal is came, like one new animal is came, but how can you label, or how can you figure out the name of that animal? Then first you are thinking in the way, hey, if something is look, if is it look like a dog, you know how the dog is look like. And if something look like that, so then you can say it is a dog. If something is look like, whether it is look like cat, oh, it is not look like cat, so it is not cat. So based on all your knowledge, or based on the previous all other related classes only, then you can label. You can give a better label or the name to the animal, right? Or in that case, to our target label. So that is called as automatic image annotations. Okay, this is actually inductive transfer learning schema. Okay, so here, so in this, we are using parameter transfers and feature transfers, transfer between classes from annotated to boundaries. Okay, so these are the things we are using here. So here we are transferring from images only annotated by the tags to the localization task. So this is one thing. So basically, this paper is published in CVPR. Uh, and CVPR is the top one journal in the world with respect to computer vision. So almost all, it is very less than 3% of paper acceptance rate, less than 3. So very huge competition every year is going on uh, while submitting papers. So if something is accepted in CVPR, so that could be something really useful. Then only so it really innovative or really research oriented, then only they can accept it in CVPR. So okay, so now what this how I mean how we are doing is, here you can see. First, transfer between classes, which means transfer the object parts between classes, such as wheels between car and bike. So what it means, if you know the wheels of car, then you can say, if you see the bike wheel also, if you know the car wheel and if you know the bike wheel, then it is easy for you to distinguish the any new wheel, right? If any new wheel comes to you and you know how the car wheel and how the bike wheel, then it is easy for you to say, hey, this is look like a bike wheel, so we can name it as a bike wheel. So that is how transfer between the classes. And feature transfer is something transferring the knowledge through the intermediate attribute level layer shared by many classes, which is nothing but if some within our neural network architecture, means within our model architecture, we are giving a knowledge about the features. Like if the image having the features like this, then only the label is. I mean, then only the label should be like this. So we are sharing that features in between the layers. So then that point is called as, like, that concept is called as features transfer. Now parameter transfer is what is this parameter transfer is. So while whenever any successful computer means any successful computer vision or CNN model architectures are published at that time, so during the publication itself, the people or researcher or scientist, data scientist and research scientist going to multiple experiments or multiple parameters actually. So after seeing multiple parameters only, they will finalize the best parameters. Now with using transfer learning, we can get the advantage of using advantage of best parameters also. If so, that is the advantage, parameters advantage and feature advantage and transfer between the two classes. Okay, so these are the major advantages we can get. Now here you can see auto annotation with segmentation propagation. So yeah, so here what they are trying to do is, in this application, so they want to build the image segmentation. So segmentation is something, I do you have anyone has segmentation idea about segmentation? Segmentation is something, if you see any image, what is the portion, like what is the portion of that image, means what is like if you see the cat in the image, so what the segmentation is, the segmentation is try to mark the place of the cat or the shape of the cat. So this kind of task is called as segmentation in very simple way. Okay, yeah, Akanksha, you can if you know, if you have any idea, you can.
Yeah, so basically, yeah, like you told us, the image segmentation is basically in which we broke down the images into various parts or subgroups, so that the complexities of image can be broken down and we can, extract more important information out of that as per our requirement.
Yes, exactly. Like, see, this segmentation is something. Uh, Basically, if you saw like a car, bike. So, as a human beings, we can see each feature of the car, and but how if you want to label it, means if you want to find the where the bike it is, or where in complete image, where which portion of the image is indicating that object. So we can get understanding that information by using segmentation. So basically it's, I'm just trying to say very simple way instead of giving full technical terms and technical words. Yeah, Panda, like you raise a hand, right?
Yeah. Okay, sir. One question. So we have been discussing about labeling or annotating the data. Okay.
Mhm.
So my question is, means how we label the data. So for ImageNet, do we receive labeled data to
Sir,
train the
can you
model,
please,
or
sir, sorry for interrupt. Can you please speak loud? I'm not able to get your question clear.
oh, okay. So we have been discussing about the transfer learning with labeled data. So my
Mhm.
question is do we get labeled data, or we need to do the labeling of the data? If we get labeled data, how we get, or if we are not getting labeled data, how we can label the data? Is there any tool for that, or how is that?
Yeah, basically this labeling things needs human expertise basically. So while generating training data like label data, we need to find a means true value, right? For means correct value for each label. See, for example, if you are collecting group of cats and dogs images. Then after collecting images of cats and dogs, so you need to label the cats and dogs, right? But if uh, you are given the mislabels to the data, then our model also our model also not works very well. So this labeling things requires the human expertise. But after labeling things, then we can so this supervised learning requires a label, and labels requires a human experts for training data.
Okay, sir. And sir,
Clear?
okay, this may be a layman question. So
Mhm.
is transfer learning capable to identify unlabeled data? For example, I have labeled a dog and a cat. If I provide a picture of pig, will it be able to tell is this is a pig or not?
Yeah, basically, it is works. It gives the feature importance, not the labels. It's not able to
Okay.
give the labels. We are not giving anything about labels. Like we'll give like see what is this transfer learning is does in a real time. So I will explain. I think in a with one example I can tell you. So yeah. Uh, See, now we have a data set, and in this data set, I have a data with respect to one image called dog and image called cat. So I have a data set of two classes, one is cat and one is dog. So if I want to develop one model or algorithm, uh, any neural network architecture, so what I will try to do, I try to make one CNN. So CNN architect basic means standard CNN or different kind of like finally I can try to see the best, even though I find the best CNN. So I will find that CNN and apply that CNN, means apply that CNN with this data, and I can develop one model, and this model is showing 85%, means 85 percentage of accuracy, for example. Now this is the scenario one. This is the straightforward scenario. Now, how the transfer learning works here? So in transfer learning, if you train the means transfer learning is using pre-trained model, like using already trained models like EfficientNet. And in today's session we are discussing about, we are using EfficientNet. So I used to talk on EfficientNet only. Normally like AlexNet and VGG, everything is a pre-trained model. So whatever the model it is, so we are taking the model, and we already, this model is already trained on ImageNet, right? ImageNet containing 100 or 1,000 classes basically. So in that classes I have a dog and cat also. Dog and cat classes also there. Now my model is ready, and in this model I have a features about dog as well as the as well as cat. Now instead of I'm applying simple means direct CNNs, means our own CNNs. If I applied this EfficientNet as a pre-training, means transfer learning, then I will take the EfficientNet here, and then later then I'm going to add one more layer. Normally, like we need to add a the first layer is the EfficientNet layer, and then later I'm going to add one simple convolutional layer, and then output layer. So output layer, then I'm going to use this same data set on this data and this algorithm, but this time I'm getting around 93% or 98% of accuracy. 98% of accuracy and results. Now, how it is possible? So, how it is possible means we already like in these images in your own data set called dog and cat, you have somewhere around 100 dogs, 100 images, 100 dog images and 100 cat images. So, but in real world, these 100 images is not enough to really find the difference between dog and cat very efficiently. So what happens in already in this pre-trained model, this efficient net and ImageNet data. So ImageNet data also consisting huge number of dogs as well as huge number of cats. Some million dog images, some thousands of dog images are there, and some thousands of cat images are there. So what it's trying to do is it trying to so it what it is doing is it take those features also, those features in feature importance, those features also added along with our own custom, our own images features. So basically, during the training, we trying to find the features, right? During the training time, we trying to find the features in the images, right? So
Yes.
at that time, we are going to have the features from our pre-trained model of dog and cat and efficient net. Along with that, we are going to have our own model features. So with the help of this too, then I can get a very good model, accurate model, as well as with less number of label is enough for my use case. Means I don't need to work on more number of labeling, because with less label only I can work, because because already in 1,000 classes, if you are using the labels or classes within that already some public are already the pre-trained images, like pre-trained public data sets. If in your problem statement, or if in your case also, if you are using something related to already present data set, means publicly available, huge publicly available data sets, if your data also related with that, then this transfer learning is playing very key role. If something completely different, then transfer learns won't work. You got it, what I'm saying now, I think.
Yes, sir.
Yeah, that is the main. With a very simple way, I can say this is how it is happening in the transfer learning. So basically so yeah, this is the very simple way to say how the transfer learning works. Okay, any questions? I think if you understanding this, then most of the means very important point of session is going to understand, like everyone can understand. If anyone has have any doubt on this, please let me know. This is very important thing. So our whole session is focused on this point only, like this way, this points only. So in my problem statement, so I am using leaf data, right? So what happens in ImageNet or whatever the model I am using? So that model is already have a information about how the images are look like leaf images are look like. So we already have means the information about the feature importance of feature importance of that images. So I can take the advantage of, along with my own custom data set, I can take the advantage of that one also, like those images also and those features also. With the help of my own features, my own data input features, and with those features, then I can make a very improved and very best model. So that is the main advantage we are getting in a transfer learning. Without transfer learning also we can do our work, but with transfer learning in a statement one itself, I like here it is mentioned. So basically, transfer learning is aims to apply the knowledge learned previously to solve the new problem faster. First point is faster, and second point is for better solution. We can have a solution, but using transfer learning, we can have a best solution and better solution. So that is the transfer learning. That is the requirement of transfer learning basically. Okay, if everyone understood this point, so that and then it is easy for everyone to understand the entire session. Okay, any raised hands if if anyone has any doubt, raise hands. Okay, I think there is no raise hands. Okay, yeah. So here, yeah. Now let's see how the win, like with respect to we are talking about segmentation, right? Now you can see the segmentation here. So this is how the segmentation in a complete image we are only figure out means we are targeting only the target means the feature. Then those like here you can see first it is in a window. So in window transfer, so in window transfer, so first it will in a first initial stage it will target this portion. Then after this portion, then it will so here you can see this portion. So in the first window, then after this window, then again it is going where the our target presents in an image. So here you can see means it is trying to extract that information. So finally, so here it is trying to figure out here this position that target is placed means target features are placed in an image. So this position the target features are placed. So in this image, this position target features are placed. So this is the how I mean so this transfer learning and this segmentation works. So segmentation, so it's something trying to like segmentation with respect to tree like tree approach. So here you can class-wise segmentation. Like here, there are different segmentations are there. Like with respect to this is the this is masked. So this kind of segmentation is masked, and this kind of segmentation is colored, and this is like edges, and this is how exact segmentation like final segmentation. So finally, we are going to get the segmentation. Segmentation is finding the boundary boxes, which is where our target is present. So that is called as segmentation in a simple way. Yeah, here in second image also you can see that. So finally, by using this mask and this by using edges, and finally figure out where the image is exist. Okay, so this is about the segmentation. Then how the transfer learning works in the segmentation is, so we already trained a model with respect to segmentation on our own data sets. So then we are going to use the same information. Like we know how a cat look like, and we know how a dog look like, how a cow look like, how elephant look like. So if we train already with our model and segmentation, then if you use that knowledge on your own data set, it is easy for that it is easy for you for the model to figure out your own data means your own data how the segmentation works. Now transfer learning with respect to image classification. So here you can see so this is like object classification when training and testing are distinct, but how this like it's something very technical. I will come to this later. So here you can see, so here you can see this is the attribute like, so this is the image and these are the features. So here it is very here it is very clear like whatever the image is consist, so it may try to like human specified high level description which consisting the arbitrary semantic attributes like shape, color, and geographical information. Like whatever we are seeing as a human. So we in while while developing a solution on a huge that means a very huge data set. So the model is means the people are trying to figure out the best model on a huge data set. So at that time the model can get a very good feature importance. So we can utilize this feature importance in our own data sets. So here you can see the data sets like any elephants with attributes over 30,475 animal images and 85 segment attributes, 50 classes with with a minimum of 92 images for any class. So it's something like this. If you see, if you are working, means if you want to figure out, if you have your own project, in your own project you need to find the classification between animals, then any model, means any mission, means any deep learning model trained on the data set which is similarly like this, like any animal data sets. So then those models feature importance are very useful for you to work on your own project or your own research. Those information means that feature importance helpful for you. Okay, so how it is implements, like with respect to image and attribute states. So this is the equations. Basically, I will try to give the equations, but I am not interested to discuss on equations because it will create a more complex for means most of the audience to understand the equations. Yeah, here you can see the data with respect means outputs with respect to transfer learning. Like experimentally, here we can see that. So with taking the advantage of transfer learning, there is a, like you can see almost all classes are predicted with 0.7% probability. So that is a main advantage we can get here. So we can get the idea about that. So here you can see so everything, like whatever the images we have in that data set, so their respective features are generated. So we are collecting all the features, and those features are helpful for transferring the knowledge. So now, how transfer learning combined with the deep learning. So here, outstanding classification, like, so what the main advantage of deep learning is outstanding classification performance in large scale visual recognition challenges. Like, so main advantage of deep learning is whenever you are working with NLP, like any text information, or if you work with any computer vision information, like images, so then only this deep learning plays a very outperformance. But if you work on tabular data or any numerical information, ML algorithms are good enough to get the good accuracy, good performance. So basically, those deep learning is highly means very good in large scale visualization recognition challenges. So here you can see that information, and learning and transfer so here you can see the learning and transferring middle level image representation using convolution neural networks. So here what is trying to say, I think we already discussed, but I am just so here you can see. So what so in our if you take case one and case two. In case one, we have our own data set. So we are having our own data set, and we are making our own very huge convolution neural network model. So what happens if you give this neural network, then this by using this neural network, it will extract the features and it will provide the outputs. But how to use the transfer learning using here? So here first I'm taking the input. In case two, I'm taking the input, and I'm making the input is equivalent to our pre-trained model. So what are the features we means, like the pre-trained model input is somewhere 150 cross 150. We need to take care our input also should be in 150 cross 150. So then first we are going to give our input to this pre-trained features, and taking the pre-trained features, and now add our own dataset features also. Now I'm going to add one more convolution layer. So then after combination of pre-trained model features and our own features, then I'm taking this here in convolution layer in complete features here. So from this I'm going to connect the fully connected layer. Then from fully connected layer I'm connecting the output layer. So this is how how the papers are proposed in 2012. So here in this papers, the author proposed the approach to reuse the pre-trained neural networks to new data sets and estimate its performance in a target task. Like, okay, so pre-trained the CNN networks on a source data like image data net for classification. Okay, the pre-trained models are works on the image data net basically mostly, but based on your own use case, you need to find the data set. We have so many data sets like car data set, image data set, and so like so many different data sets are there. But based on our use case, we need to find the data set. But ImageNet is a very popular and very standard data set. Like next, what we are trying to do is we are adapting a layer is then trained with the data in the new data set to solve the difference between two tasks. So what we are doing here, so we are taking complete this knowledge as a one layer. So completely we are taking as a layer. This is layer one and this is layer two, and this is layer. So these are the two convolution layers, and this is the fully connected layer three, and this is our output layer. So this is something like that. So we are taking the adoption of the features in a layer, okay, and which is going to apply to the our new data set. Okay, so basically this is applied, this is started in 2012. Now this efficient net is 2020 actually, so I'm just focus on the updated one, but this transfer learning starts in 2012, but our efficient net is published in 2020 and 21 also, in 2020 ending and 2021 beginning in 2021. So now it is stabilized solution, so that's what we are using this efficient net up means latest means most recent powerful pre-trained model, I can say. Yeah, here this is the complete framework. Like here, how a feature learnings takes place, and how the transfer learning takes place, how the classification learning takes place. So here you can see. So this is our source task, like convolution layers. This is a complete. So I can say what exactly, like you can see this is one box, one separated box, and this box is called as our pre-trained model. In our pre-trained model, what we are doing is we are training the images called ImageNet. So there are different classes are there and different images are there. In that model, or in the model, we are having some n number of layers, because some n number of layers are there and some different architecture is there. So that architecture and everything is there. So those model and architecture is trying to uh, find the features, trying to extract the features from images. So after finding extracting the features, then trying to have a final fully connected layer as an output layer. Then from that it is going to figure out the labels with respect to each class. Now we already have this information, we already have this model, so we are directly using this model in our own customized data set. This is our own customized data set. So here we have only limited number of output classes, like 4 classes only we have in our own customized. So what we are doing, we are taking the advantage of transfer learning. So we are directly using already pre-trained model layers and apply and taking the layers here and adding our own layer, based on our model, like based on our own data set and image size, then take the output layer, and from that I'm going to decide how many classes I need. So here there are 4 classes required. So this is with respect to our target task. So this is what exactly with respect to complete framework of how means how transfer learning works. So here you can see this is, so in this phase we are trying to learn the features. This our pre-trained model is try to learn the features and give you some performance. But so these features I'm going to give the so that whatever the features it learns, it is going to give the feature transfer. Okay, so here that will takes place here, And after that, on top of it, I'm going to add my own layers, and from that I'm going to add my final output layer. So that is called as classifier learning. So this is how, this is the main framework, means a standard framework of transfer learning. So here you can see the performance, like here you can see. So without transfer learning and with transfer learning, there is a huge difference you can see. So there is a accuracy around 77 without transfer learning, but with transfer learning 97, 63. Here we have 84. So there is a huge, means there is a huge difference. There is a improve. We can improve the our own mod, means our own standard model with the help of transfer learning. So that is the advantage basically we are getting using transfer learning, instead of making own standard model. So we can use the existing model. So mind this is and one more thing, if we are using the data which is related to the already existing data, for example ImageNet. So you are also working on developing a animals classifier, classification task, or plants classification task, or plants disease task. If you have a already if you have a knowledge about if any model, if we have any data set with that images or with that classes. So we on that model, on that data set, the models are we are build the models, right? So then whenever we are using our own customized data set, we can utilize those models, and we can utilize those features. We can find the features importance from the models, and we can just so with the help of that, then we no need of collecting, then there is no requirement of collecting huge number of images and true values, and there is no requirement of collecting more number of images or data. So that is the advantage of transfer learning. With the help of transfer learning, you can give a less amount of data set is enough, means small, means very not very less, like medium size data set is enough to get a good results. And the data also should be similar with the publicly available data set where the model is developed. Okay. Yeah. So the conclusion is transfer learning is a still hot topic in various fields like image classification, text classification, recommendation, and transfer software engineering also. So this is all about transfer learning. So anyone have any doubt on this? I just try to give you idea on this, not a very detailed way. Like that will makes all, means many audience to confuse and difficult to understand. So if anyone's more interest, and if you want to go very in detail, so I will provide this documentation. You can go through the document and so go to the slides, and you can see everything in detail. Yeah. But as of now, I'm focused on all audience. So in the first phase, I will try to understand about how the transfer learning works, and what is the mechanism transfer learning using, and how to solve our problem using transfer learning. Okay. Yeah. Now I able to see two raised hands. Arul, Mani, please ask your question. Like,
Good evening, sir.
yeah. Good evening, madam.
Sir, in classification segmentation, you showed you showed one picture, sir.
Yeah. Yes.
How we calculate that picture?
Calculate means, I mean,
Sir,
what you are.
sir, please go to the slide, sir.
Okay.
Classification, sir. Image
Yeah.
classification.
Yeah. Here you are asking like here, right?
Sir,
This segmentation, final segmentation.
sir, go next slide, sir.
Okay. So image classification, transfer learning for image classification.
Yes, sir. This class attribute matrices. How we calculate this class attribute matrices?
So basically, this is like a based on the features. So this class attribute message is generated based on the features basically. So for example, if zebra is there, so zebra can contain black, and so here you can see what is the pattern that zebra will contain, the features. So here you can see the attributes, means with respect to animals. So here you can see the animals. If you want to, as a human beings, how can we recognize the animals with respect to shape, or with respect to color, or with respect to size, like that, right? So those are
Yes.
the attributes, correct? So yeah, now with respect to each animal, what is the features, means what is the value of the feature, means what is the value of each attribute. So the model, it will learn by itself these features. I'm just visualize that information. So we are not going to teach the model to learn in this way or something like that. We just train the model during the training only. Whenever we train with the data, so during that time, the model learn everything, learn by itself. That is the main advantage we are getting in deep learning. So we are getting that advantage because of back propagation kind of stuff.
Okay, sir.
So
Sir, also.
in a simple way, so this I'm just explaining. Like I just want to everyone, like I just want to give you exact explanation for how image classification works with respect to transfer learning. So here, let us take, means how I'm just repeating the things to understanding everyone. Like okay, so can you please tell me, as a human being, how to identify an animal? Like,
It
yeah, hello.
depends upon the face and
There are different attributes are there, like based on a shape, or based on a color, or based on. So there are different. So here you can see black, white, blue. So this is with respect to colors, and big, small, and hands, and pads. So long legs, so tail. So there are. So this is the difference. So here in here you can see different attributes. So with respect to each attribute, what is the value? So here you can see black and white. So this is the value. It's something. Black represents some features. So here this is the feature. With respect to zebra, if you see the zebra and if you see the scale, complete scale, I think I can mark it. So yeah, if you see the scale, so with respect to each feature, what is the value? What is the value in a sense? What is the feature? I Yesterday I told you, right? Like each image is represented in the numbers, like 0 to 255. So if you remember, like so in a complete feature map, we are finally represents our images with the numbers. Means finally we are teaching the mission with the numbers. So what is the value? What is the value we are getting here with respect to each attribute? So that is that those things are learned our pre-trained model. So our pre-trained model already learn, and if we want to use this pre-trained model on a specific only pig, lion, or cow, in my own task, I have only three classes, and I want to find the out of three classes. If I give the image of the image of any animal, so you need to say which is the animal it is. So if I use this, means if I use my my own data set and my own thing, so I'm getting some kind of feature extraction. But if I use this information along with my own features, if I use this information also, then it is very easy for me to identify exactly each animal. So that is a point actually. Is that clear? Still doubt?
Yes, sir.
Mapping here. Actually, this is different animals. You are saying.
Sir, I'm not able to hear you. Some noise. I'm listening some noise.
Very
There is a
sorry,
noise.
actually.
Yeah.
See, here I'm having the different data set.
Sir, can you
So
please, can you please speak loud now? I'm not able to
sorry,
hear your voice.
I'm very sorry. Actually, I already speaking loud only. But anyways, no problem.
Yeah, now
Now,
it is clear.
no, am I audible? Am I audible?
Yeah. Yes,
Yeah.
yes, yes.
Sir, actually, this is different images, and we are going to differentiate between these two. When I'm having the same data set with different sizes, how can I differentiate? Whether will it be useful further to have these kind of attributes matrices?
No, no, no. If you have a same image, means if, for example, in that case, let us take a different classes of dog. So dog, there are different kinds of dogs are there, right? Now,
Yes, sir. Actually, I'm not talking about the different classes. Same class of dog
yeah,
with
same
the
class.
different sizes.
Yeah, different sizes are there, but you see, if you are comparing dog with cat, whether it is size, whether whatever the size the dog has, so 95%, like what is the accuracy it gets, so that much of percent is able to say it is a dog. But
Mhm.
inside a dog, if you use the different again, if you use the different kinds of dogs, then again you need to train based on that information, means based
Okay.
on. So whatever you want as an output, we need to train that information to the model first.
Hmm.
See, for
Okay, sir.
example,
Fine. Actually.
in a dog also, for example, in a dog, you want a small dog and big dog. This is not realistic. I just want to give you idea. See, in a dog itself, it means you have a cat, you have a cat and you have a dog, and you have only two classes. But again, in the two classes, you want to make two more classes in each class, like small dog as well as big dog, and small cat as well as big cat. Then in total you have four classes, right? Then if you label these four classes and if you feed the model with these four classes, then model will tell you whatever the input you are giving and whatever the label you are giving, whatever the training you are giving, then it will try to find the features from that. So try to see with respect to those features actually. You got it what I'm saying?
I got it, sir. Okay. Yeah.
Yeah. Yeah,
Thank you.
but
Thank you, sir.
normally, like if you see with respect to cat and only dog, whether whatever the size dog has, it is not a matter for the model. So
Mhm.
if I saw the shape or the shape features something like this, then it is dog. If I saw the shape features something like this cat, then it is says cat. Whether it is small, big, it is not. But still, if you want to go detail, so you need to train regarding that.
Okay, fine, sir. Fine, fine. Thank you, thank you, thank you.
Yeah, thank you. Any questions?
Sir, one more question, sir.
Yeah, sure, ma'am.
Sir, why we use the classifier?
Classifier is a final output layer where we need to inform how many classes we are going to take. So classifier is something here we are so till now everything is all about the features only. This classifier is a final layer. So in this layer, we are giving number of classes, whatever we have, with each features. So if the set of features is something like this, then this is the class. If something like this, then this is the class. So classifier is something of final output layer, which will give you information about the number of classes we have in our problem.
Okay,
And
sir.
in real time, we are using softmax. So softmax is a kind of activation function. This softmax, what this softmax is doing is like we have a probability, like what is the probability distribution range? Means what is the range of probability distribution? It's 0 to 1, right? So the probabilities lies between 0 to 1 normally, correct?
Yes, sir. Yes,
Yeah.
sir.
So this what this softmax is doing, this softmax, see, we have a 4 classes. So out of these 4 classes, so which means class 1, class 2, class 3, and class 4. So this softmax, this final classifier layer with softmax is trying to predict what is the probability of each class within complete one. Like this class 1 is somewhere around 0.1 something, this one is 0.2, this one is 0.6, this one is 0.1. So can you please what is the output by using this information? Can you please tell what is the output, what is the output of the class? So
Class 3.
whichever, yeah, the class 3 is the output, right? So whichever the means which whatever the class having highest probability distribution, then that can be a means that is the class for that input. But so what this softmax distribute the probability distribution among all classes. So that is the purpose of the class, means within the 4 classes, which is the class of that image, means which is the which class?
Strongest class.
Yeah. Is that clear? Like,
Yes, sir.
yeah, yeah.
Yes,
Okay.
sir. Thank you, sir.
And yeah, if you see the summation, it is the summation value is 1. If you see the probability distribution summation, it must be 1.
Yes, sir.
Yeah. So with this classifier is try to find within all available classes what is the highest probability of the class. Means which class having highest probability. Yeah.
Hello.
Any other questions? Yeah. Yes.
Yeah, hi, sir. Myself Subhan. So I have a question. See, I just want to work on some MRI scans related to some disease on the eyes, but I don't have my own data set. So in that case, can we use such kind of data sets which are publicly available, like
Yes. Yeah. Yeah.
Efficient
Basically, yeah. Whatever you are asking, I am understood. Like you are trying to
right,
ask about. You are looking for MRI, like scanning, like retina diseases, right?
right,
So retina diseases and data set with respect to that.
right, correct.
Basically, there is no straightforward answer for that. Means data sets we need to check with different universities. Basically, universities
Mm.
like Stanford and some major universities and one more we have Cornell universities that maintaining one kind of platform where the people
Okay,
can upload their data sets. So
okay,
and Kaggle also one platform where we can find different data sets. So here, so this is data set in Kaggle. So come to here and see. I'm just searching in front of you. Uh, retina or eyes retina. I think you can see that. Yeah, yeah. Here some data sets are there.
okay. So you mean to say these data sets are similar to EfficientNet or ImageNet, right, sir? So that
Yeah.
we can
Yeah.
readily use these. Mm.
Yeah. So take this data set, try to apply whatever I am going to show you, like whatever I will explain in hands-on. Try to apply the same thing here in this data set and try to see the results. If the results are okay for you, or if you are able to, if the data means if the model is able to learn this data set and figure out the patterns in this data set, then you can use the model. Otherwise you need to build the model based customized model, your own customized model.
Yeah, sure, sir. Got it. Thank you.
Yeah, basically these are very specific data sets, right? So that's
Right,
what
right.
no, there is no generalized means the people are not taking. And one more interesting thing, one more thing is there, paper with code. Yeah. So this is a website, and this website is useful for all folks who are looking for research kind of stuff. So here you can see the data sets. So here also you can find different data sets, like image data sets, like all popular data sets. So here you can see, is there any pre-trained models are there or not? See, for example, this is my ImageNet, right? Like in ImageNet. So here you can see this is the ImageNet, and in ImageNet, my task is I'm looking for the task called image classification. Okay. Now let's see this task with respect to this data set. So now here you can see what are the pre-trained models we have on this task. So basically, this is a good platform where we can get a good, I mean, all information about all latest available. So here you can see the year of publishing. So our efficient net will comes here. Like you can see the efficient net in 2020, end of the 2020, it is begin. Means there is some different variations of efficient net is also there, but efficient net is a stable and more efficient. Means most efficient, useful, more useful pre-trained model. Here you can see that. So this is also efficient net. I think most of the things, yeah, so many things are there with the efficient net. So here you can see EfficientNet L2, which is 2021 path. So this website will provide all information with respect to image and as well as all available pre-trained models and which model is giving what is the accuracy and all. Okay. Yeah. Thank you.
Great, sir. Thanks for that.
Yeah, I think we need to take a break. So I will try to means we can again meet at 6:30. Now it is 6:15, 13. So I'm trying to give 10 minutes of break. So I request everyone please join at least by 6:30. So yeah. Yeah, I think most of the participants are written, so I'm just waiting for 2 more minutes. Okay, so yeah, so till now we discuss about what is the problem statement, like what is the project we are going to discuss. Like we need to identify the diseases on a leaf using cassava plant leaves. So what is that is something like image classification only. Like we need to feed the machine with images of each leaf, like diseases of each leaf, and we will label each image with their respective diseases as a class, and we have the data. And what our target is to get the model, to get the best high performance model, like 90% of accuracy. Then in future, whenever we train or whenever we feed a new image, that cassava leaf disease image, then model is able to identify the diseases among one of our class. Correct. So this is about our problem statement, and we have a data, and we have a evaluation. As a evaluation means, for evaluation we have a accuracy as a matrix, and for this purpose we means, instead of developing our own custom, means our own convolution neural networks, we can make a use of already pre-trained, means already trained and published convolution neural net means neural network models. Like and there are so many models are there. So today we are going to solve our problem with efficient net. Efficient net is very stable and most recent pre-trained model with good results, like good performance. So that's what I choose, and I choose efficient net. So I'm going to use the efficient net pre-training model on my problem statement, and we will see how this transfer learning is works. Okay. Yeah, and any questions on transfer learning, or any questions so far? Yeah, I think no. It's I think everyone is clear. So now let's solve our problem. So I'm going to start the hands-on session. So in between, if anyone have any question, please let me know before starting my hands-on session. So I need to give some time here, basically. So this time, this training requires huge time. So I need to, actually I already trained the model, and I saved the model already. So we will use that model as a final. So yeah. Okay, so now I am not going, means now I'm not going to work on running the query and showing everything in detail. So now I'm working, means I will I will go to each step and I will try to explain the purpose of each one. So instead of running in front of everyone, so because there is a huge running time required. If I start running, so I need to run everything. So I'm not. I mean, so we need to wait at least for 3 hours to complete the training time. So to complete the training, so here you can see 1242 seconds. So just use it like 1242 seconds, nothing but by 60. It's around 20 minutes per each epochs, and we have a 8 epochs. So 120 165 minutes. So which is nothing but again 60. So literally it takes 3 hours time. So I already trained just whenever I think I start training around 1 o'clock and I complete the training around 4 p.m. So it takes around 3 hours to complete the training actually. So that's what I'm not able to run in front of you. I will show means I will go to each line and I will try to explain the purpose of each line, but I'm not able to run the uh, code. Is it fine for everyone? Like, is it okay?
Yes, sir.
So okay, yeah. Now I'm going to start the hands-on session. So I hope everyone is clear with uh, project problem statement, and everyone is clear, understood at least in high level about what is a transfer learning. Uh, so still any doubts, or if anyone feels I'm a bit fast, or any if you need anything required again, I will repeat again. Like I will try to repeat things if it is required. Like if anyone found difficulty with the speed, like okay, yeah, I think everyone is clear. So I will start my hands-on session. Okay, so again, in this hands-on session also, we are taking the same number of our steps like what we discussed yesterday. Like in our first step is we need to first we need to install all required libraries. So basically, we are using Kaggle platform. So in platform itself, everything is installed. So I'm not going to install the libraries. Only few libraries are very particular libraries, or libraries only not installed in Kaggle. So at that time only I need to install the libraries. Otherwise, I can directly import the libraries, whatever I need. And in this session, we have two frameworks. One is TensorFlow, called when TensorFlow or Keras, we can say both are same, like same in terms of TensorFlow is like Keras is a part of TensorFlow. TensorFlow is a final deep learning framework. Okay, and PyTorch is a one more framework. So we need to decide which framework you need to use, or and along with that, what are the libraries you want in your project. And data collection is not required in this case, because the data is already collected and they are given the data for us, means for the problem. And then later we need to load the data set and do the data analysis and EDA. And pre-processing means convert our raw image or human understandable image into machine understandable format. So which is going to be input to the model. So then we need to build a model. So this time we are using instead of CNN, we are using EfficientNet. But EfficientNet is also something like CNN only. It's like a complete architecture. Like it's like a very complex architecture, complex neural network architecture with the different operations. So I think in future or in next in upcoming session, I will give you more information about EfficientNet. Like I will give you a separate session. What is the EfficientNet? What is the what is the architecture of EfficientNet? And what is the logics or what is the operations are used in EfficientNet? We will discuss in details in future sessions. But here one more point: whether EfficientNet or LXNet or VGG, anything. So everything is transfer learning only. So the words are with respect to the model only. Okay. Okay. Yeah. Now this is with respect to our model building. Then after that, we need to train the model. So this thing is constant for all problems, and prediction on the tested data as well as the feature data. Feature data is nothing but we train the model is everything is ready. Then we are going to deploy it. So in future, means after 3 months or 4 months, so one of our users, means who are you are targeting the users, like in cassava leaf, the farmer, like any farmer who wanted to know what is the disease of this leaf, then he can upload the image or he can give the input as that image. Then the model, the algorithm will predict the disease for that image. Okay, so that is the prediction on text as well as the feature data. Then we need to see about, we need to think, we need to concern about the evaluation. So we are using accuracy as a metrics. So we need to check the what is the accuracy we are getting, whether that accuracy is sufficient or not, whether 90% in your use case. Or so, for example, if you see in with respect to business aspect, so then you need to make sure whether your accuracy is good enough for business or not, whether I need to improve or this accuracy is enough or not. So after finalize that information and after finalize everything, you need to do the deployment and production. Deployment is you need to provide your model to the end user. So that is called as deployment. Okay, so these are the major steps, like these are the main major steps required in almost all computer vision problems basically. So with respect to NLP, some few changes are there, but mostly this is the standard steps required in almost all DL or ML projects. Okay, so so with that words, so in our first step, so we need to import the libraries, right? So in this project, we are using NumPy, Pandas, Image PL, like to visualize the image. We are using uh, image library called PIL and OS MATLAB for visualization. Seaborn also for visualization library, and scikit-learn for shuffle the data, and utility, weight, class weights, and max and min scale, like for pre-processing, and random, and cv2 for reading the image, and image augmentation. For image augmentation, I'm using augmenters, and this is warnings to ignore the warnings. And here we are using TensorFlow. In TensorFlow, I'm taking the TensorFlow TF. From models, I am taking the model as well as sequential. From pre-processing, I am taking the image. In image, I am taking the image data generator. This is the method we need to generate. We need to extract the data, image data generator. And in layers, we are using dense layer called fully connected layer. Dropout is a one more layer, and activation, an input layer, batch normalization layer, and a global average 2D layer, global average pooling 2D layer. Okay, and I'm just importing layers also, layer also. Now callbacks is something like to control, to get the best during training. We can get the best model out of all models. We can get when we are going to, I mean, when we find the best model, then using this callbacks we can save that model. So model check, so model checkpoint, and uh, so this is a reduced later and earlier stopping something. If you find something is going to be overfitting, you can stop the model and says, hey, you are going to be overfit, something like that. So for that we need earlier stopping, and this is the Gaussian delay and two categorical, to convert our classes into two categorical. And then we are going to import in application. Yesterday I shown you, right, in Keras, Keras, in Keras we have applications, right? In Keras, this is the Keras documentation. So go to the documentation, see the Keras application, So in Keras, we can these are the popular which available pre-trained models on ImageNet. Okay, so all are means all are used means all are developed on ImageNet, and the values are the parameters and the accuracy and top 1 accuracy and top 5 accuracies with respect to ImageNet only. So here you can see that information. Okay, this is VGG 16, VGG 910, ResNet 50, ResNet V2. So all are there. So we are going to use this EfficientNet family. In EfficientNet family, I'm using EfficientNet B3. Okay. So this is library. This is sorry. This is the this is the application, means the pre-trained model I'm going to use in my problem. So here you can see how to import that model. So TF, Keras application, and EfficientNet B3. So here I did that. So here TensorFlow, Keras application, and EfficientNet B3. Okay. Now with respect to pre-processing, we require center graph, random graph, and random rotation. So what this is, something like data augmentation. So that data augmentation is something I will tell you. Like if you have a limited data or very less data, you can do the data augmentation to get the more data. What is that? Is, see, for example, I have a one image. See, this is my image. One dog image is there. Somewhere the dog is something like this. Now we are going to do the data augmentation. So data augmentation is nothing but something Docker. So now that this is our original image, what I am doing, what I will try to do is I will try to take this means I will try to take that image and rotate that image with 90, somewhere around 90 degrees, 180 degrees, and with now I want to make it as a black and white image. Now I want to make it as a somewhere sharpened image, something like this. We have so many filters, right? So many filters and so many options are there. So with one image, I can get different kinds of images with one image. So this process is called as data augmentation. So generating a data using the image with different perspective is called as data augmentation. Okay, so that's what. For that purpose, we required this pre-processing like random rotation, center graph, and random graph. Like instead of taking this complete image, I can take only this graph only, or I can take this graph, something like that. So many options. I mean, so many things are there. So by using those things, we can generate for each image. I can generate so many number of images, so many number of images with different perspective, with rotation, with different perspective we can generate. Okay, so for that process called as data augmentation. Basically, it is required to give you more information about the data. It is helpful to get more information. So I'm running the query, but by the end I'm going to stop. I mean, say, during training time I'm not going to run. I'll just skip the running, means running the training. Here now what I'm doing, so our importing things are done. So now let's look into the loading the data sets. Now here you can see this is the path actually. So here our data sets are there. So here you can see this is the computation data set in this so I'm just making just taking the images, training dot images, and I'm specifying the training images path here. Okay, now here I just specify the training file. Here you can see what is the information we have in training file. So I think we can see here. So the training file is something where we can see the information like image ID. So whatever the image is present here and their respective label, as well as the path of that image. Okay, so that is present in this CSV file, train CSV file. So we are importing that file here. So here, if you want to know the labels, here you can see that. Okay, so now sample samples df, and the column name is labels, right? So label. Now labels, and now the values. Valid count. Okay, I think it is not. Sample df. Here you can see with respect to each class how much, I mean, how many images are present. So I think this label 3 is healthy, so the class healthy. So with healthy we are having more number of images with diseases like 4210. Here you can see that information.